Let's talk about the 3.0 objective, solving quadratics using the quadratic formula. Here's number 11 on your review. It's important when you're using the quadratic formula to make sure that one side of your equation equals 0, which we already have on this example. So now we just need to identify our a, b, and c. Our a is 1 because it's the number in front of x squared. And if there's no number there, the coefficient is 1. Our b is negative 8, and that sign is very important. C is negative 7. Now we're just going to plug this into the quadratic formula, which, in case you forgot, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So we're going to plug this all in. We're going to start with our b. So the opposite of negative 8 is positive 8 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And remember, we call that number underneath the square root a discriminant. And that's the very first thing that I do, is I just find my discriminant. And like we discussed in the 2.0 video, you can do that just by plugging in negative 8 squared minus 4 times 1 times negative 7 into your calculator. Or you can use order of operations. It's important that if you plug it into your calculator, you put parentheses around the negative 8. So I found my discriminant to be square root of 92 over 2. Now I'm going to simplify. And to simplify, I need to find the perfect square that goes into 92. I know that 4 goes into 92 23 times. So I'm going to rewrite the square root of 92 as the square root of 4 times the square root of 23. The square root of 4 is 2. And I can't take the square root of 23. Sorry about that. So I'm just going to leave it in the square root. Everything else, noticed, I didn't change anything else except for rewriting the square root of 92. Now, the last thing I need to do to see if I can simplify anymore is look at the numbers on the outside of the square root. I see that all of them are even, all of them are divisible by 2, so I can simplify by dividing each of them by 2. So the numerator becomes 4 plus or minus square root of 23. And we could put that over 1, but when we have a fraction over 1, we typically don't write it like that. So I'm going to leave it just like this. And that would be my answer for this question. Number 12 on your review is another one that you're supposed to use quadratic formula to solve. And so I want you to first notice that one side of the equation does not equal 0. So that's the very first thing we're going to have to do is rewrite it so that one side does equal 0. So I'm going to subtract 7 from both sides. We're not going to combine that with the negative 6x because they're not like terms. Now that one side equals 0, we'll find our a, b, and c. And then we'll plug it all into the quadratic formula. Almost ran out of room there. That's a 7, sorry. All over 2 times a. Okay, and then we're going to find our discriminant. And that number here is 288. So we'll rewrite this using the discriminant in place of, or putting it where it should be. Now we want to find the perfect square that goes into our discriminant, which is 144, which is 12 squared. So I'm going to rewrite this as the square root of 144 times the square root of 2. Square root of 144 is 12. Square root of 2 can't be simplified, so I'm going to leave it like that. Now I look at all my outside numbers and I see they're all divisible by 6, so I divide each one by 6. And I'm done. That's as far as I can simplify it. And that's it for quadratic formula. So just to real quick, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That should be all you need for the quadratic formula. If you have questions, let me know.